So apart from the missing filter capacitors, we see that there is also a lot of work has also been done on this PCB. As we can see at this level, it shows that the pulse width modulator has been replaced before. Here is the switching MOSFET. Here is the pulse width modulator that determines how fast this man switches. Yeah. So apparently this power supply unit should have lots of issues. Power supply unit should have lots of issues. Physical observation reveals something should be missing here. What could that be? No, it's okay, nothing is missing there. But however, the two filter capacitors are missing. There's a swollen capacitor here at the backlight section. Yep. Then the pulse width modulator has been replaced before. Aside that, there is nothing else. So with stuff like this, most of the time there is no need to waste much time trying to repair. It is a small TV, a small power supply, so we just go straight to the output section, to the secondary of the power supply, and see the voltages that are required to turn on the TV. They will get the voltages from anywhere else, and even from an external power supply, and inject there and see what happens. Then also, if we look carefully at this power supply, we see that we have just 3 diodes at the secondary. 3 Schottky diodes, high-speed diodes at the secondary to filter the voltage from the switch mode transformer. Just 3 of them. Then if we flip the board over, we see that 2 of the trans of the diodes are connected in parallel. 2 of them are in parallel. Then the other one is standing all alone. So the 2 diodes that are in parallel, their job is to filter 12 volts. This other one standing alone, its job is to filter 5 volts. Yeah, as indicated here. Here we have 5 volts. Here we have 12 volts. Then ground. So right away, I'm going to look for 12 volts and 5 volts from an external power supply, inject it in there, and then we see how it goes. So where we can easily get 12 and 5 volts is from a computer power supply. So we are going to I'm going to get a computer power supply, because from there we have a good 12 volts and a good 5 volts. We inject it there and see what happens. So I'm just going to solder the cables, the required cables on the required positions. This yellow is for 12 volts. So I inject it not at the output of the diode, but at the supply point, because the voltage I'll be injecting there. Now let me see. Yes, I have to inject it at the output, not at the input of the diode. Yeah, because at the level of the input there are other networks that pick up from there. but it is advisable to inject at the output because the voltage from the external power supply is already filtered, has already been rectified, excuse. So that's how we do it. So I connect it at the output of the rectifier diode. Here is for the 5 volts. Then let me look for a ground. For the ground wire, I'm just going to tie it here. I'm just going to tie it to this. I'm just going to tie it here. And I screw it there in its position. Yeah, it is solid. So I'm going to plug it in, plug in, and I tie this screw to link the earth. To link it here. Then I tie this other screw here for the earth. As you can see the earth washer here. This washer here is for earth. So I tie this other one here. Oh, I forgot to replace this capacitor. Yeah, anyway, we'll replace it after. First of all, let us test and see if the TV turns on or not. Yes, that's okay. So with that done, we're going to test it right away. So here is a power supply I'm going to be using. It's a computer power supply, a very old one. You can see that debris in the cooling fan. So that's what I'm going to be using. So I'm just going to link up, wire the cables respectively. Yeah. Just going to wire the cables. Yeah. Yellow goes to yellow. Yellow is 12 volts. Black is ground, or better still the negative. And then the red is 5 volts. Red is 5 volts. So this is quite an easy power supply to work with. That's why this method is quite easy. So I'm going to turn it on right away. So we must remember for this computer power supply to turn on as a standalone device, you have to short circuit PS on the green wire and black, so that anytime you plug in to your power cord, it just turns on, it switches on immediately without the need of the computer motherboard. When I plug in, the fan will start spinning. That will indicate that the power supply is on. Okay, there is no short circuit, nothing is shorting. Okay, let me plug in. Yes, it is on now. So let us check to see if the standby light of the TV is on. Okay, as you can see, the standby light is on. So let me hit the standby button, and let's see what happens. Okay, you see what happens. It is on. So let us wait and see what displays on the screen. Okay, that's it. So the TV has turned on. It is on. It is on now. As you can see, here is the wiring. That's the cord for the computer power supply. Here is the wiring. Here is it. Yep, here is it. Here is it. As you can see, so that's it. So we have successfully turned on this TV with an external with a computer power supply. Okay, the next challenge we have here is that the computer power supply is quite big. It's too big for this TV. So using it there is going to be a waste. So I got a power supply unit. This is from a computer monitor. This should be around a 14 inches computer monitor or less. Yeah. The unfortunate thing here is that the only output voltage from this supply is 12 volts. Yeah, we only have 12 volts from it. We can only have the only output voltage here is 12. Yeah, it's 12 and 3.3 volts. 3.3 volt will not be enough for this TV set. Else the display screen will remain white. Yeah, there will be no images. It will remain white. If there was enough time, I would have gone through it and see. We inject 3.3 volt. You will see how the screen will remain white. But if we inject 5 volt and 12 volt, the screen will be everything will be okay. But if we inject 12 volt and 3.3, the display will remain white. There will be no graphics. So this power supply only has 12 volts output. So what we are going to try is to drop down, use a voltage regulator 7805. I just hope the section that uses 5 volts here doesn't pull more than 1 amp, or else the 7805 will not support. However, it is an experiment. We are going to try it and see. So we are going to go through the process together. Here is my 7805, the voltage regulator. Here is a filter capacitor I'll use along with it for stability, 10 volts at the output. At the input, there is no trouble. Yeah, because it's going to tap direct from here. So right away, we are going to go through the process. Let me just solder the wires behind the camera. Yep, so here we have 12 volts. So we tap 12 volts from here to the voltage regulator. That's 12 volts. Then let's tap the ground wire. Here is the ground. That's the ground. Then we put it aside. Here we have voltage regulator. Tie it on a solid heat sink. Yep. Oh, this screw seems to be too fat for it. I have to tie the voltage regulator on a solid heat sink for proper heat transfer. Okay. That's the input, the common, and the output. so. Here I got this 12 volts cable from the power supply unit. Here is a ground cable from the power supply unit. There's a ground wire, and here is the input. And here is a filter capacitor that I have to connect at the output. This is how I'm going to do it. Okay, so next we are going to check and see if the voltage regulator is working, if it is in good condition. So I'm going to plug in the power cord to the power supply. Okay, plugged in already. So I'm going to test input and output of the voltage regulator. Yes, we have 12 volt at the input. Then at the output, what do we have? We have 5 volt at the output. The voltage regulator is working perfectly well. So now we're going to inject the voltages into the TV and see what happens. Okay, here we got our 12 volts. Pick 12 volts direct from this same point to prevent any losses, to reduce losses along the line. Then our common ground, we take it from this same point still to reduce. It will also help to reduce losses. That is the ground. This is the ground. This is 12 volts. Then the 5 volts, now we are going to pick it from, we are going to pick the 5 volts from here. So 5 volts, we pick it up from this point. Okay, so our power supply circuit is complete. The power supply circuit is complete, so I'm going to plug in now, and let's see what happens. Okay, I want to plug in my power cord now to the power supply board, and let's see what happens. I hope there'll be no spark. Okay, I just plugged in. If you look well, you see the standby light is on, which shows that the standby light is on, faint blue, as you can see.